Okay, today we are going to cover two related topics: generating a linear equation using the slope and a point, and the second one is by using 2 points. And they're closely related because we calculate slope with 2 points, but in many cases we're already given a slope value. In this example, we're going to be looking at slope, and we call slope m quite often, and I'll look at a generalized equation in just a second. But we're going to use this first case where we use the slope of -1/2 and passes through the point -4, 4. That's -4x and a positive 4y value. Note that our slope is negative here in this case. All right. So let's take a look. And first of all, the general form of the equation. We want an equation that is what we call slope-intercept form. Y equals mx plus b, where m is the slope, b is the y-intercept. And note that the y equals b when x is equal to 0. So in other words, no matter what the slope is, if the value of x is 0 here, then m times 0 is 0 plus b, so y equals b. The very significant thing is that in most general form equations or most standard form equations, y equals b, or whatever term is the furthest one, the constant term, is your y-intercept. And we'll get deeper into this, much deeper into this actually in Algebra 2. But notice that y here, going back to some earlier discussion, is the dependent variable. Okay, because the value of y is going to depend on what happens as we change the value of x and apply the slope and the constant to it. And so x is the independent variable. Okay, just a little extra information here as we go into the slope calculation, but the dependent variable will vary as we change the independent variable. And it makes sense from applying good English to these definitions. Okay, so let's move on to our graph. Here's a graph, and it is scaled normally with an XY grid. And notice that the point -4 and +4, it should be +4, sorry. Let's see, make that a plus. -4, 4 is on our chart, and we have a slope. We said that our slope was m equals -1/2, and you can see, as we've talked about before on slope values, it is going downhill from left to right, which is consistent with a negative slope. Okay, so how do we calculate this equation? Okay, well, what we do is we take the slope value and we apply it to the equation, and we say that y, pause here for a second. Okay, sorry about that, I had to cough. We use a standard form that y minus y1, that would be this 0.1 here that we have, 0.1, y minus y1 equals the slope value times x minus the x value that we know. Okay, so let's plug this in. We have y minus y1, which is 4, equals 1/2 minus 1/2 times x minus a -4. Okay, again, watching your signs. Oops, let me clean that up a little bit. -4. And now we can go ahead and collect our terms. So we have y minus 4 equals, now -1/2 times x. And then we have this plus minus a -4 makes that a plus. So we have minus 1/2 times 4, so it'll be minus 1/2 here times 4. So now let's do a couple more steps. Real simple here. Y minus 4 equals minus 1/2 x, and minus 1/2 times 4 is going to be minus 2. All right. And now what we're going to do is we need to get y by itself. So using just some general algebra that we learned in Algebra 1, we're going to add 4 to both sides. And I'll go ahead and note that as a step here. We're going to do a plus 4 here and a plus 4 over here, because whatever we do to one side of an equation, we have to do to the other to keep the equation in balance. So this becomes y equals minus 1/2 x. Minus 2 and plus 4 becomes plus 2. Okay? And that is the equation. Notice the general form here, using the point that we know, right here, we use this y minus y1, and we use x minus x1 using that point, and then the slope comes from the slope that we are given to get this equation. Now, what if you think back for just 1 second quickly, we said that the y-intercept right here was equal to the b term when x is equal to 0. And so going back to our equation, notice that that y-intercept is in fact identified right here as 2, and we look at our equation, and there it is at the point 0, 2. So if I plug in 0 for x, sorry, we will get y equals 2 times 0 plus 2, which agrees with the y-intercept on our graph. Okay, so that's the instruction for using a point and a slope. And we're going to pause here. I think what I'll do is make a separate one for using 2 points.